Hi guys, welcome to lesson 3.1 on quadratic equations. So this whole unit is on solving quadratic equations. And for our first lesson, we're going to learn our first technique. We're going to learn like 3 different techniques for solving quadratic equations, and then we're going to learn about quadratic equations that have non-real solutions. So we're going to learn about a new type of number, but we're not doing that yet. So the most kind of simple approach to solving a quadratic equation is to isolate x squared. And this is only going to work for certain types of equations, which is why we're going to develop a few different techniques for approaching them. But for equations that this works for, if you can get x squared by itself, you can use this technique. So we're going to start by isolating x squared, or the term that's squared. Okay, so let's do that for our first example. So we want to get x squared by itself. Let's highlight that. We want to isolate this. So to do that, we need to get rid of the plus 8, so we'll just subtract 8 from both sides. That will give us x squared equal to 108 minus 8 is 100. Okay, not too bad. Once we have the x squared, or the squared term, by itself, we want to get rid of that exponent, right? So we're going to do the opposite of squaring, which is square rooting. So we're going to undo the exponent by square rooting both sides. So, okay, I square root both sides. So square root of x squared, that's just x. And then square root of 100. And here we have to be a little bit careful, because there are two numbers that give us 100 when they're squared. There's a positive number and a negative number. So we might immediately think the square root of 100 is 10. That's the positive square root. There's also a negative square root, because negative 10 times negative 10 is also 100. So we need to express this as either a positive or a negative 10. So this symbol is read as plus or minus, and it means that it could be positive 10 or it could be negative 10. So there's really two different solutions here. So our third step is to remember plus or minus. There is a positive square root and a negative square root. Okay, so this first example is done. We have two different solutions to this equation. X could either be positive 10 or x could be negative 10. And we're done. Let's go through our second example, and that will lead us into what step 4 is. Okay, so for our second example, we're going to follow steps 1, 2, and 3 like normal. So our first step is to isolate whatever is being squared. So here we have an expression that's being squared, but that's what we're going to isolate. So to isolate x minus 11 all squared, we need to get rid of minus 5. So we're going to do the opposite, which is to add 5 to both sides. That leaves us with x minus 11 all squared equal to 44 plus 5 is 49. Next thing to get rid of is our exponent of 2, and we get rid of that by square rooting both sides. So we're going to do the square root, square root of x minus 11 squared. The square root and the square cancel, leaving just x minus 11. And then when we square root 49, we need to remember plus or minus. So this could either be the positive square root or the negative square root. So plus or minus 7. Okay. So that's all the steps we did in our first example. And in our first example, we were done. In this example, however, x isn't fully by itself yet. We have x minus 11 equal to plus or minus 7. and we want just x. So it's really common to say, okay, well, we can do this by just adding 11 to both sides, right? The problem with this is that over here, we have two different numbers. So if I just write add 11, do I mean add 11 to the positive 7? Or do I mean add 11 to the negative 7? And some people are tempted to write that this will then be plus or minus 18, but that's not actually true. So we have to be careful here. So what we're going to do is, because we have two numbers over here, we're going to split into two cases. So the first possibility is that x minus 11 is equal to the positive 7. I'll just write that as regular 7. And the second case is that x minus 11 is equal to the negative 7. And now I'm going to solve each of these cases individually. So now I can add 11 to both sides. For my first equation, I get x equal to 7 plus 11 is 18. Okay, now I'm going to add 11 to both sides of my other equation. And here I get x equal to negative 7 plus 11, which actually gives me 4. So the answer didn't end up being plus or minus 18, it ended up being 18 or 4. We have two different solutions. Okay, so our step 4 is a step that applies to only some equations, and it's to split into two cases if needed. And then continue to solve from there. Okay, so that's kind of a basic overview. We also want to talk about number of solutions. So both of these examples ended up having two solutions, and that's a common thing. Quadratic equations can have two solutions. So just like we've seen, this equation to solve, we would start by adding 18 to both sides. That would give us x squared equal to 63 plus 18 would be 81. And then to get rid of our exponent, we square root both sides. And we remember plus or minus, so we get x equals plus or minus 9. And we have two possible values for x. Okay, so that's kind of the typical situation. We get two solutions. In some special cases, we're only going to end up with one solution. And here's where that would happen. So say we have x plus 12 all squared equal to 0. To get rid of the square, we know that we need to square root both sides. So on the left then, the square root and the square cancel, and we're left with just x plus 12 equals, and then we want to square root 0, and the square root of 0 is 0. We might be tempted to write plus or minus 0 because we're being good mathematicians and remembering our plus or minus. But in this case, this is the one number that only has one square root, because a positive 0 and a negative 0 are the same number. They're both just 0. So for 0 only, we don't have to worry about plus or minus, and we can just say that if x plus 12 squared equal to 0, then x plus 12 is equal to 0. Okay, now we keep solving, so we're going to subtract 12 from both sides, and we end up with x equal to minus 12 as the only solution to this equation. So there's only one x value that works. All right, the last situation is a situation where we might end up with no real solutions, and we're specifying real because later on in this unit we're going to learn about numbers that are called imaginary and numbers that are called complex. And quadratic equations that have no real solutions will have either imaginary or complex solutions, but we haven't learned that yet. Okay, so when does this happen? x squared plus 21 equals 4. We would solve this like normal, so we're getting x squared by itself. We would subtract 21 from both sides, and we would end up with x squared equal to 4 minus 21 is minus 17. All right, but this is a problem. So no matter what I choose for x squared is going to be a positive number. If x is positive, then a positive times a positive is a positive, so x squared is positive. If x itself is negative, then a negative times a negative is also a positive, so x squared is also positive. So no matter what x is, x squared is always positive. So basically, x squared equal to negative 17 cannot happen in the real numbers. So we say this equation has no real solutions. Okay, so that's an overview of solving basic quadratics and the situations where they would have two solutions, one solution, and no solutions.